At this time, I'd like to introduce Don Cooper of Siemens PLM, who will be the presenter, and Kyle Laruto, the application engineer, who will be doing the demonstration. Don, take it away.
All right, Tom, thank you very, very much, and welcome everyone to today's webcast on Solid Edge Design Better. If you're looking for ways to design better products and gain a competitive advantage in your business, we'll show you how. As Tom mentioned, my name is Don Cooper. I'm presenting on behalf of Applied CIM. I have with me today Kyle Laruto, and Kyle will actually be helping by showing some of the technology within Solid Edge and Synchronous Technology. I will introduce you to some top industry challenges that we're offering an exciting way to achieve both your business and your design goals. But more importantly, we're going to discuss how companies like yours are using this technology to gain a competitive advantage in addressing some key design challenges. Lastly, we're actually going to show you inside this demonstration the live software of Solid Edge and how it can apply to your business. Before we get started, I'd like to thank Edison, too, for the use of this image. What you see here is an experimental car that they designed and developed to compete in the Progressive X Prize competition in Detroit. And the goals were to design this car, seat 3 people, handle, accelerate, and operate just like any 4-passenger car on the market. And it had some pretty aggressive efficiency standards. I'm pleased to announce that Edison 2 won the award of $5 million by using Solid Edge with Synchronous Technology. Now, it's anyone's guess when you'll see this car on the road, but the point is that Solid Edge with Synchronous Technology is helping companies like Edison 2 design better and gain a competitive advantage. So, as we get started, I'll introduce you to Applied CIM. Applied CIM technology has been enabling companies around the integrated manufacturing industry for over 23 years. Companies like Sherco and A1 Engineering and General Equipment are just a few companies that Applied CIM Technologies works with and is delivering value from. Applied CIM has worked with over 1,800 accounts nationwide, have a very high customer retention ratio because they have a professional staff and over 100 years of combined manufacturing expertise. It's our goal at Applied CIM to someday earn the opportunity to put your company's logo on our slide as a company receiving value from the business relationship with Applied CIM and Siemens Technology. So as we get started, I'll just ask an open-ended question, and that question is, what are your barriers to design better? Well, goals may differ from group to group or person to person on the phone here today, but if you're looking for ways to go faster, improve something in your design process, or gain a competitive advantage against your competition, you're not alone. What are your goals? But more pressing, what are the barriers you have to achieving them? Some of you might instantly know what those challenges are, and some of you might need some time to think about it, but that's okay. As you give this some thought, let me just walk you through some top industry challenges that I hear consistently. The top industry challenges, we worked with a company called Aberdeen Group, and they found that there's some key challenges that almost all engineering manufacturing companies are struggling with. What they found is that 39% of designers struggle with this model creation using traditional 3D CAD software technology. If you've ever used a traditional 3D CAD software tool, or you might be considering moving to one, you're probably aware of some of the technical challenges that could or will stand in your way. These systems require that models be built in a certain way. They use complex rules to preserve the size and the shape of the model. Aberdeen also found that 57% of the engineers lack the ability to alter or change the existing designs. Traditional CAD requires these models to be built in a certain way. In fact, over half of the respondents claimed that these traditional history-based systems would sometimes and many times require the original designer to make those changes. And if they're struggling with it, it might just be better or easier to change it themselves or remodel it and move on. Lastly, is your company looking for ways to reduce your overall product development costs? One of the areas they do that is in the area of reusing imported data. What we found is that over 44% of the companies we surveyed struggled with imported reuse, data created in another system by another person, and they just struggled with using that. So what we're going to do is we're going to look at ways to improve your design process. Well, you might be asking yourself, yeah, sounds good, Don, but where do I start? Well, industry research shows that investing in technology tools in this area is a very, very value-rich area. I'm going to take you now through a walk that's going to show 3 specific areas that we can look at to improve your business and help you achieve your business goals. The way we do that with Solid Edge to help companies gain a competitive advantage is very simply 3 unique areas: accelerated design, faster revision, and better reuse. The first area of accelerated design is for faster time to market, so you can respond to your customers with blazing fast speed and response time. Next, we're going to look at how we help companies make faster revisions for higher repeat business and lower cost to increase your margins. And then the last point we'll show you is how Solid Edge with Synchronous Technology supports a concept called better reuse with existing data or imported data, regardless of the author or authoring source. This can help you cut your development costs and gain the competitive advantage you're looking for. So let's get started. The first area I mentioned is looking at accelerated design. I know, almost every company you talk to in this 3D CAD space either can say this or will say this. But what I want to show you, and we will show you in the next few minutes, is the way that we use a disruptive technology that we call synchronous technology to help achieve this area of accelerated design. Synchronous technology is a patented technology available only to Siemens PLM software. This is an innovation that has dramatically changed the game in the product development process because no pre-planning is required in the design process. Well, since no pre-planning is required, the Solid Edge user can design in a history-free environment and accelerate this design process. The user does this by focusing on the design intent versus the design tool, not wasting time trying to predict future changes like your traditional 3D history-based systems. You also can achieve full digital prototyping inside of Solid Edge. We do this by leveraging a hybrid 2D, 3D environment. Unlike other 3D CAD systems, Solid Edge offers you a common user interface for both the 2D users and the 3D users. We can offer this because we've developed this product from the inception to be a 2D and a 3D tool. We also understand the need to import and export 2D data and respect that most manufacturing companies are still being driven or being driven by a 2D print or a drawing. So we help leverage that in the design process, and we look forward to showing you that in an upcoming demonstration. Additionally, Solid Edge gives you the user freedom to redesign on the fly and respond to your customers' demands with lightning fast speed. We do this with a unique capability inside of Solid Edge. It's actually a technology called Live Rules that we're going to show you in just a second. So, accelerated design. What could this mean for you? The unique capabilities I just reviewed can help your company secure a competitive advantage and get products to market faster, and in some cases up to 25% faster. I will now pass this over to Kyle Aruda, who's actually going to show you what we mean by the accelerated design inside of Solid Edge. Kyle, take it away.
Very good, Don. Thanks. So what we're going to look at here today is exactly what Don is talking about. And one of the ways of doing that is to look at a particular design that I've been working on. And I've been working on this with our team. And what we have inside of here is a high-performance motorcycle. And inside of this motorcycle, I have been working on different parts of it. But one of the things is my boss came to me and said, hey, you know, Bob's on vacation. He was working on this brake handle. I need you to go out and finish off the design that he was working on. So all I have to do is simply go out, take a look at that design, and start modeling it the way I need to go and model it. Now again, I didn't start this design, but I need to go finish it. And what Don was talking about is the ability for Solid Edge to simply give me the tools to go out and start designing the way I need to design. In this case, I just want to be able to finish off this part by using the geometry of other parts around it. I don't have to worry about drawing a sketch or anything. All I have to do is simply grab that face, rotate it around, and I'm able to start my new design. And as I do this, the tools are going to be right at my fingertips on how I want to go through and select things. Now, if there's different options I can go through here and select, Solid Edge will allow me to do that. And if I need to, I can easily change my mind at any point in time whenever I go do that. All this information is right here at my fingertips. And so let Solid Edge help me decide on which face I want, If I don't like the one I want, then it gives me the option of selecting the ones that I need. And as I do this, Solid Edge also gives me the opportunity to understand how the information I want to pull from that particular face. It gives that information right at your fingertips. I can also come in here and say, well, I really don't need a face, I just need to select an edge. And again, be able to get that information and quickly change that on the fly. Solid Edge gives that to me right at my fingertips. Now, as you can see, I've gone through, I've made a couple of changes. I can quickly turn off the assembly if I want and take a look at my part. And you know, I went over here and I created a couple of cutouts, but you know, those cutouts actually look like a hole. Well, Solid Edge will go through and actually find those as being an actual hole, and I can come in here and I can add any kind of tolerance that I need to that particular hole to give me some clearance. It goes through and does that. One of the other things Don was talking about is the ability to work in a history-free environment. What do we mean by that? Well, those of you who actually work in a history environment, you know that you deal with a history tree over on the left-hand side. And in most systems, you know, I can go through and take a look at what those features are. But with Solid Edge, we have basically a feature list. It's just a collection of features. I was able to take that hole and literally drag it and drop it above the protrusion. In a history-based system, you wouldn't be able to do that. That's just showing you the flexibility inside of Solid Edge that you don't have to worry about your parts regenerating. They're regenerating instantly on the screen. And Don, that's how we accelerate design.
Oh, excellent, Kyle. Some pretty amazing stuff when you start to really see how Solid Edge with synchronous technology in a history-free environment with no pre-planning, the ability to really start to focus on the design versus the intent of the designer. So amazing stuff. So I want to now move into the next competitive advantage with Solid Edge. It's the ability to facilitate faster revisions. Life would be pretty good if we could capture the first design intent up front and never have to make changes to it. But the reality is we have to make changes to most of our designs. We're making revisions for multiple reasons. So allow me to describe what I mean by faster revisions. So in the fast-paced world of design and manufacturing, winning new business and making profit on projects can literally hang in the ability to respond and efficiently answer customer demands. Solid Edge with synchronous technology has this unique capability that we talked about earlier called synchronous technology that allows designers and engineers to make fast, flexible changes to both models and drawings in a constraint-free environment regardless of the authoring source. So the way Solid Edge facilitates this is the engineering concept I introduced on my previous slide of live rules. So we're going to show you that in a little bit more detail in just a minute. It's like having an experienced co-pilot running with you because it interrogates the model, it analyzes what would be the potential next steps based on what you want to do. And it's not enough. The most valuable part with Solid Edge synchronous technology is these models don't regenerate. Kyle showed you how he moved that up in the feature tree around the collection of features, and it didn't have to regenerate the entire model and crash and blow up and go play around with it. You focused on the design intent. So what does it mean for our customers? Solid Edge with synchronous technology allows customers of Solid Edge to make revisions in minutes instead of hours. This is also helping you secure the competitive advantage that you're looking for. Let's take a look at what we mean by faster revisions.
Very good. Thanks, Don. So one of the things you can think about is, what is a revision? Well, a revision can actually be performed with a part that you've actually designed inside of Solid Edge, or making a revision to another part that someone else designed inside of Solid Edge. But you know, a revision can actually come from a different source. Let's say we have a sister company who actually uses a different CAD system, in this case SolidWorks. And we bought this company who already had SolidWorks, and they've given us a design, but we need to make a revision to it. And so with that, I didn't make this part. So how can I go make changes to it? Well, again, with the tools that Don talked about, we can go through and we can say, well, I want to simply make the change to these holes. And again, Solid Edge will actually go through and find those holes for me. Now, the revision that I have on my desk tells me that we can't have a counterbore. We actually need to have this as a simple hole, and we need to change it from an 8mm to a 10mm hole. Well, that's not a big deal for me with Solid Edge with synchronous technology. I'm able to do that and do that very quickly. The other thing is we need to move the distance between the two mounting holes that I just changed. And in doing that, Don introduced to you what's called live rules. And if you look down at the bottom, you see a row of icons. Well, that's live rules. And Don was saying that is a co-pilot. Well, what do we mean by that? Well, literally, as I go through and I make this change, as I start selecting a single face, notice all the other faces that it has selected. That's what live rules is. It's looking at the design intent of this particular model, and it's finding that intent automatically for me. Now, this also happens whenever you go through and add a dimension. One of the things that they said in the revision is that the dimension that needs to be between these two mounting holes needs to be 95. Well, as I go through here, we have a couple of options of which way I want to go. So we have directional dimensions inside of Solid Edge. And as I select each of these options, you'll see that this system is highlighting the faces that it's going to modify. And so I can simply come in and tell it I want to go 95, but I want to grow symmetrically, because that's the intent I want to put into this model. And notice it automatically does that. Live Rules picks that information up. So you can see quickly I'm making these changes. And as I go through this, I simply ask this question: how would have you made that change in your CAD system on a part that wasn't designed in your natural CAD system? Another way that we do this is going along what Don was saying with hybrid 2D, 3D abilities inside of Solid Edge. Is a lot of times as I go through, I really like to look at a cross-section of this part. So this is just like in draft. When I want to get a cross-sectional view of this particular part, I can actually look at it in 3D and actually see what this is, and I can dimension to that cross-section. Now the thing about this is it's actually driving that 3D part from that cross-section, and I want to lock down that 9 millimeters so that anytime I go through and make a change, it's going to maintain that as being 9 millimeters whenever I go do that. To prove that to you, I just need to come in here and say, well, the distance between these two faces is 40 millimeters, but I really need it to be 50. And this is where Live Rules comes into play. Now remember, I selected the 2D geometry, that section, but it's actually changing my 3D part. And if you notice down at the bottom, Live Rules picks up the fact that this part was symmetric. Again, that is the intent that is inside of that model. That's what Solid Edge brings to the table with Synchronous Technology. One of the other things is I need to go in here and I need to remove some information. So I just want Solid Edge to go in and recognize a few things. That being a cutout, I can simply just go in and delete it because I don't need it anymore. And Don, that's how we have faster revisions.
Yeah, amazing stuff, Kyle. I was actually just watching you go along there. Amazing, good stuff. So every time I see that demonstration, I'm amazed at the power and the capability that Solid Edge gives the engineer and designer with the flexibility. The final competitive advantage that Kyle and I will share with you here on the phone is the ability to facilitate better reuse. Consistently around the globe, I talk with manufacturing companies, and they struggle with reusing data. The ability to reuse it from existing suppliers and other companies, whether they're acquiring them, getting the assets, or doing collaborative design environments. It seems to work fine when everybody uses the same exact system, but the real world and the reality is not everyone is on the same system. You either need to bring it in from a catalog source or another program. So Solid Edge with Synchronous Technology allows you, the user, to make these precise changes to imported geometry by adding 3D driving dimensions to any piece of geometry. I have customers tell me consistently that many times it's much easier to make changes in Solid Edge than it would be even in the native software that the product was built in. So inside of Solid Edge, another unique capability is the ability to make these direct imported edits by pushing and pulling and using a capability that we call steering wheel. And so Kyle's going to show you in just 1 minute what we mean by a steering wheel to drive these edits and changes. And I also mentioned to you earlier about the power of Live Rules to capture this design intent. So the question to you on the here in the audience is, what could live rules have on your business? What kind of impact with the ability to reuse these, better reuse? Only you can answer that question. We believe that it means a competitive advantage in responding to your customers quicker. So ultimately, it's about lowering your overall development costs. So Kyle, let's take a look at imported reuse, better reuse, importing some geometry.
Very good. Thanks, Don. So as we go through here, there's a couple of different ways you can think about reuse. One of the ways is to actually reuse data that we already have on 3D models. And Solid Edge gives me the ability to do that inside what's called a feature library. I'm actually able to grab geometry from other parts, whether they were designed in Solid Edge or not, it really doesn't matter. All I have to do is have them inside of Solid Edge, and I can save that geometry over into my feature library. In this case, what I've been told, and again in my my paperwork that's here on my desk, is needed to take out that cutout, and I needed to put in a different cutout inside of here. And I'm going to reuse that from an existing design that we had. And as Don was saying inside of the steering wheel, think about it in this case, and this is the reason why we called it steering wheel, is you literally want to grab the geometry and steer it in the direction that you want it to go. I can precisely put in the dimension where I want to place it, or I can say, well, I want to move this in an XY direction along a particular plane and be able to place that right inside of my part. And as I do that, I can simply come over here and say that's where I want it, and I want to go ahead and I want to attach it. And as I do, it automatically removes that material. That was the design intent I had inside of there. That's one way to think of how you want to reuse data. Another way of doing that is taking a look at it from a 2D standpoint. Now, a lot of us still have 2D drawings laying around in drawers and on our computer hard drives. A lot of times we get in 2D drawings from a supplier or from a customer because that's all they have. Well, what can you do with that inside of Solid Edge? Well, we have complete control over AutoCAD drawings inside of Solid Edge. I have layer control, I have dimensional control. But one of the things that we bring to the table is a unique tool called Create 3D. No one else in the industry has this. And what it literally does is it steps you through the process to say, I want this to be my front view. I want to select the views that I want. But you know something? Rather than the system going through and moving and folding this view for me, I'm going to tell it how I want it to fold. And it's automatically going to place this inside of my 3D part for me. So we can see that now I have my front view, I have my right view, they're all in the correct locations, and now I can go through and I can start creating my 3D geometry. And one of the things I want to bring your attention to is the actual dimensions themselves. As I go through here, I want you to watch and see what happens with those dimensions. Now, inside of Solid Edge, I can go through and I can select regions of how I want this to start creating my geometry. And I can simply select which way I want this particular one to go, or if I want to go in both directions. Sorry about that, I just hit escape. But what we can do is have the flexibility. Solid Edge gives you that feedback instantly on the screen and which way I want to go with this particular part. Now, since I have that 2D information here on the screen, I can easily go over there and select that's how far I want that particular solid to go. Now, I told you to watch the dimensions, and you'll see that some dimensions actually change colors. That's because they literally moved from the 2D over to the 3D part itself. They literally jumped off of that 2D and went on to the 3D. And you're saying to yourself, okay, I really didn't see it, I blinked. Well, again, you have the different options of what you want to choose, how you want this part to extrude. But watch the 25 millimeters. As it goes through and I extend it and I say I want to extend to that particular point on my 2D, that 25 literally jumps off of that 2D sketch right onto my 3D model. Now, one of the things about Solid Edge inside of here is that once you use sketches, once we see that you're done with them, you can actually restore them to come back to life, because that's exactly what I wanted to do, is I want this to come back to life because I'm going to use it again. And I'm going to use it to place this particular one at a thickness of that 10 millimeters. Watch the 10 dimension. It's actually going to move, what I call leap off of the sketch right onto my 3D model. And like I did before in my other 3D model, I want to lock that down. So whenever I go in and make some changes, I want to lock it down to be that 10 millimeters. The other way of doing this, to think about it, is that, as we talked about before, of having that co-pilot along with me. In this particular case, I'm going to make a change to this dimension. Notice that it automatically found symmetry. But again, we have which direction I want to go, and it's highlighting that face for me. Well, as I go through and I start making some changes, that co-pilot is helping me understand how it should modify that particular model. If I choose to go in a different direction, notice that the changes that it makes a change to the geometry a different way. Let me show you a third way I can do this. Again, we can go symmetrically inside of here. So I have 3 options just by using the tools that are right at my fingertips inside of Solid Edge. And Don, that's how we can better reuse the information that we have in our arsenal.
Excellent. Very, very good, Kyle. Amazing stuff to see that 2D data. And as I travel globally, I still see so much 2D geometry that's out there. Companies are struggling with how to leverage that 2D. How do they get it into their 3D systems that they've gone to today? And you just showed a great way how companies can leverage that 2D intellectual property and design better with Solid Edge by bringing it in. So the real proof is through what our customers say and what our customers see. For Applied CIM, one of the customers we work with is A1 Engineering. They were able to increase their competitive advantages in their marketplace. They build high-quality molds and tools, custom-built to print parts, and they're a leader in their sector, producing for the high-tech, high-quality molds since 1971. And the company has established this reputation in the marketplace by, being innovative in their design. They focus on the complexity in the mold design process with high-quality manufacturing in the aerospace, industrial machinery, medical, power generation industries. And what they found was after adopting Solid Edge with Synchronous Technology, their designers reported that their CAD maintenance issues were significantly reduced. The part sketching that they relied on was virtually eliminated by using Synchronous Technology, and they report back to us that it literally only takes a third of the time needed that typically would have taken to change a part, and that's translated to them in increased productivity, overall business improvement. They're able to generate new business, get new clients, and the question I would have for the people on the call is just imagine for a minute what that improvement could have on your business. Imagine the cost savings, the new projects you could get, the reduced cycle time, the image of your company improved, the quality of life your engineers and designers could have. It really is a game-changing competitive advantage for the companies that take a serious look at Solid Edge with Synchronous Technology. So really what it means for our customers, our clients, is Solid Edge with Synchronous Technology. Simply put, it's a way for you and your company to design better. Solid Edge with Synchronous Technologies offers accelerated design for faster time to revenue, faster revisions for more repeat business, and better reuse for more competitive advantages, and most importantly, a competitive advantage for your company. So with that, I appreciate the time. Your time in attending today's webcast. We've stuck to the half hour here, and I'd like to turn it over to the audience here. Are there any questions from the field? Did we generate some interest around what-if scenarios? So I'll open it up to the team. Tom, if you'd come back on and help facilitate that, I would appreciate it.
Well, thank you, Don. Thank you for your time. That was a great presentation and demonstration. Are there any questions? If so, please use the chat line or speak up.
Yeah, Tom, we're here on our end, and we did get one coming in on the chat here, and the question was, where did you get that feature that Kyle brought in? Where did that feature come from, and what type of file formats are we able to support there? So I'm not the technical guy, so I'm going to pass that to Kyle so he can answer that. Okay?
Sure. Great question. And that the feature library It literally is open to whatever geometry you have. And that particular one just came from a past design that we had, whether it was designed in Solid Edge or we grabbed it off of another part that we imported either from a step file or from another CAD system. That's the beauty behind that feature library, is that any geometry that you bring in the Solid Edge, you can grab it, throw it in that feature library, and bring it back on to any new part or any new design that you have. The other question, I believe, Don, it was the file types that we bring in.
Yeah, that's a common question that I know as we travel around the world that we get a lot of questions, is what type of file formats can you open? So Kyle, I'd like for you to address two things. One is talking about a direct import of a file type, and then also what types do we have?
Sure. So basically, to bring a file into Solid Edge, it's literally almost any file. You see a whole list of file types, you know, from Parasolid to JT, NX, AutoCAD, ACES, CATIA, IGES, Inventor, MicroStation, ProE, SolidWorks, SDRC, STEP, STL. It's basically any kind of format that you can get. Solid Edge is going to be able to open it up, use synchronous technology to make those changes. Now, on the other side of that, the flip side of that is what can you save it out as? And it depends upon what you're asking, either from a 3D standpoint or from a 2D standpoint. From a 3D standpoint, you can see them here on the screen. Again, it's Parasolid, JT, an ACES format, CATIA translator, which is an additional add-on to Solid Edge. It's the only translator that is an add-on. IGES, STEP, all those different types, even the 3D Adobe can be saved out, and also KeyShot for high-end renderings inside of there. And then if you're talking about the drawings, if I take a look back at that drawing that I had, there's different types of formats that we have inside of there as well from a 2D standpoint. And as I go through this, one is AutoCAD, IGES, again the Acrobat, and then MicroStation. So those are the types of files that we can bring in and also export out.
Great, Kyle. Thank you. So it looks like a wide variety of ability to directly bring data in from multiple sources and get them back out to those people that need to consume the data in the right format. Okay, Tom, how are you doing on your end? Anything on your end? Questions come in on the web chat line on your side?
Well, yes, I guess there is one question. It's about our new release. There's a question asking when ST6 is going to be released.
Yeah, excellent. So we'll be releasing ST6 to the market later this month. We're having our Solid Edge University in Cincinnati, Ohio, and then we'll be announcing the availability of that product later this month. I believe we'll go into production shipment 1st of July timeframe, and so be looking for that exciting update. I've been privy to some of the enhancements that are coming out in that product. I don't want to steal the thunder from Karsten in Cincinnati, but suffice it to say, I think you're going to see a tremendous amount of exciting things come out in that release, along with a lot more user enhancements coming directly from our customers. So that's be looking for it in the next few weeks. Okay.
Thanks, Don. I don't think we have any more questions anymore on your end.
Nothing here on my side. So I'll pass it back to you to wrap it up, Tom.
Well, okay. Thanks, everybody. Thanks for taking the time. Yeah, I think the synchronous technology is a very advantageous tool for almost any company, and we surely thank you for taking the time to look at it today. If you have any questions, we are here to answer them. And again, thanks, and have a good day.
Thanks. Cheers, everyone. Bye-bye.
Bye now.